Hello, everyone, and thank you for attending our first Insight call. Today, I am pleased to host Jen Paisler, who is an Associate Professor of Industrial and Systems Engineering at Rensselaer Polytechnic Institute, otherwise known as RPI, in Troy, New York. There, she researches and teaches courses on how math and computational resources can be used to solve logistics and supply chain challenges. Welcome, Jen, and thanks for attending today.
Thank you for having me. I'm excited to talk about some logistics and supply chain challenges.
Awesome. Well, you and I met, I want to say about 5 or 6 years ago. I don't know if you remember this, but you were hosting an event and you said to the audience that you'd like to solve hard supply chain problems. You remember that?
Yes, I do. And I appreciated you took me up on my offer and gave me some hard problems. So
I did. And so for the audience, just so you know, I asked her, could our industrial powered cars potentially be used to increase inventory turns? And the short answer was no, but Jen sort of educated me as to the whole concept of capacity and how you have to increase your front end capacity overall to increase turns. And I think the lesson I learned is that things have to be moving more and sitting less, right? Did I get that right?
Yep.
Good.
And we have to focus on bottleneck processes. Yep.
Yeah. So I was a pretty good student that day, but I feel like there's so much to learn from this because our customers are continually coming back to us and saying we have 3 challenges right now. Oh, actually 4 challenges. We can't get people. We are growing so fast, mainly because e-commerce is exploding. We have to kind of adhere to our customers' demands for speed, which is off the charts. And we need to do it all accurately and with less resources. And so understanding capacity is a huge thing. And I thought who better to talk about that subject than you. So maybe go a little bit into what your role is like at RPI and your students, and maybe what challenges you see that they need to be ready to solve.
Yeah, so I mean, I have a fantastic job in the sense that I get to work with really, really talented and smart young people. I'm in an industrial and systems engineering department. And so I teach classes on, supply chain design and facility design, as well as more kind of mathematical courses like operations research. And so what I think is exciting for your listeners is if you have hard supply chain challenges, one thing I would hope you guys are doing is looking to the field of industrial and systems engineers. These are students that are excited about supply chain logistics problems, and then they come with some really great analytical, mathematical, and data skills. And so, the challenges you mentioned are hard. These are hard things, right? People want stuff fast, they want it quickly, they want it cheaply without very many resources. That's hard. One of the things that we have at our disposal now is data, right? So we, in theory, should have better information. And if we have better information, we can plan better, which means we can use our resources more efficiently or get our stuff faster, right? And so, our students kind of bring that big picture systems engineering, lots of analytical, computational, data science kind of skills. And then they're interested very much in supply chain and logistics. And so I have a super cool job that I get to teach students in these courses. And then I also do research on these similar topics.
Okay, really cool. I'm glad that. And what sort of companies do your students end up working at?
So I always say every company should be hiring an industrial and systems engineer because every company has a system or a process, and that's the things we're engineering or optimizing. Where do our students go? They kind of go everywhere. I mean, there's a number of students going into consulting companies. There's a number of students going into kind of the big Fortune 500, a lot of them in supply chain roles. Some of the, GEs, the Unilevers, the Targets, the Amazons of the world. And then, all over the place, there's people in public policy, nonprofits, and, kind of everywhere, but those are a lot of the common places.
Okay, fantastic. So a lot of our audience is in the supply chain, and many of them have seen an increase in business, hopefully, really since COVID. A lot of people are forced to buy things online. That created pressure, especially for people who had never been in e-commerce before. So they've got to ramp up and somehow figure out how to deal with that. So what can you teach the audience today? Teach the folks who are struggling with capacity, or maybe just help them understand it because they're struggling with how do I staff? Do I take the risk of bringing on more people? What if things change? I guess maybe just enlighten us to that subject.
Yeah, that's wonderful. And so, I mean, this is something I actually teach in my class, and this is something that I'm going to walk you through kind of a quick lesson that I hope you guys take away from. And, you know, question like you said your clients have is like, how should we plan capacity levels? And, you know, depending on what business you're in, that might be, yeah, how many people should we hire? How many machines should we buy? Things like that. And this is a question that I always pose to my students, and I always say, I've actually answered this question wrong before. And so we walk through kind of how you common maybe faults of how you might go about this, and then why a little bit better idea of making this decision. And so I'm going to actually give you the answer. And this is a rule of thumb. There are much, much more sophisticated tools, could build some complicated simulations and stuff, but as kind of a rule of thumb, a way to answer these questions is to make sure that you're not using just average performance. Variability is a big thing in capacity. And so the rule of thumb here is you should think about 80% average utilization when making these decisions. And the reason here is, as your clients know, the world is not deterministic. You don't get exactly the same number of orders per hour every day, Monday through Friday. Instead, there is variability. There's spikes up and down. And so because of those spikes up and down, you need to make sure you're accounting for that variability, and therefore should not be planning on 100% utilization. So that's the answer. Let's like walk through kind of why is this 80%? Okay. And so I'm going to walk with you, Kevin, through this example. So I'm going to ask you some questions. It's super simple. I'm sure your clients will find this, okay, this is really easy, but just to get some context. So let's say you have to handle, 500 units per hour, right? So that's what they need. They need, they're looking at maybe receiving or whatever, or somewhere in their facility, and they have this requirement. And someone comes through and they've done maybe some time studies, they have historical data, and they can look at it and say, that one person can handle, on average 100 units per hour. So my question then, is how many people should we hire, right? So any thoughts on, this? How many people do you think we should hire?
Oh boy, I didn't know you were going to put me on the spot here. Okay, well, let's see. I'm going to say 80% of 500 is 400 divided by 100. I'm going to say the answer is 4.
All right, so let's walk through this. Okay, so just to give you, I do like math, so I'm going to put one equation in here. This is the only equation I have. It doesn't even have any math in it, but just as an average resource, here's one way you could think about it. It's like how many units handled per an actual time unit. So that's like the actual number that was done divided by how many they're capable of doing, right? So that's one way to think about resource utilization. What did I do over kind of what is my capabilities? There are other measures, but this is one of them. And so if you think about, if we hired 5 people, right, each of them on average could do 100. So we would be able to, do 500 units. And that's how many they're capable of, and that's how many we need, right? And so we would be at 100% utilization. So, 5, you could say, okay, that's one answer. So that's an option. What if we hired 6 people? Okay, so if we hired 6 people, we're not having them all work because you only need 500 units, okay? So on average, they're only fulfilling 500. But now I have the capability of them doing 600. So the denominator is 600, you do the math, it's around 83% utilization. And you can say, okay, what if I hire 7 people? Okay, so again, you still only have work for 500 units, but you now have the capacity to do 700 units, so you're around 71% utilized. Okay, so hopefully that makes some sense. That's on how to use this calculation, but we still haven't answered the question, how many people to hire, okay? So obviously, if I only hire 5 people, that's going to be cheaper than if I hire 7 people. So maybe the answer is we should hire 5 people, okay? The problem with that is that we are assuming 100% utilization. So what we're assuming is that every time and every hour, there's actually 500 units of work to be done. So what happens if your supplier is late today and they don't show up for 10 minutes and those people are doing nothing for 10 minutes, not at any fault of their own? You will never get that time back, right? But on average, you had 500 units per hour. So that means sometime down the road, you're gonna have to be making more than 500 units per hour out that system to make up for that lost time, right? That's an example of variability. And because of that variability, I would recommend in this example, either to hire 6 people or 7 people. And how do we get at which one of those? That goes to how variable is your system. So if your system is pretty constant, almost every hour you actually have 500 hours of or 500 units of work, then you can get close to 5 people. Maybe that's fine. But if sometimes you only have 200 units, sometimes you have 1,000, sometimes you have that, it's really variable, you're going to need more people. Okay. So I'm going to go back to why does this 83% kind of show up on the next slide. Any questions about that?
No, my answer was wrong though. I had 4, so I get it.
Okay, that's all right. I'm putting you on the spot here. No,
that's okay. I remembered you had talked about you have to have way more capacity because things happen. So it's not, the 500 isn't a perfect situation where that's just not realistic.
Yeah, because you need to plan for the fact that, yeah, sometimes you're not going to always be able to complete that. And that means you have to make up for it in other times, right? And so where does this, 80% come from? This is a graph that I'm going to, kind of walk through. On the x-axis, you could think about that as resource utilization or release rate. You could think about that. So at 100% capacity, that's that blue line. That means all my resources are exactly 100% utilized, right? And at 0, it means, okay, nothing is coming in your system, right? So there's nothing, you have a bunch of, resources, nobody's using them, right? And at 100%, they're always used 100% of the time, okay? So that's what's going on. You can think about the x-axis as resource utilization, and on the y-axis is cycle time. So you could think about cycle time from a, e-commerce community. It could be when the order was placed to when it got delivered, or from when the order arrived to your facility to when it got out of your facility, right? So that time you could think about as the cycle time. And obviously we want that time to be smaller, right? So one of the things a lot of your clients are demanding is really fast speed, right? And so if you look at here, as you have probably experienced, if you just visit a restaurant or something at a low point in time, your time from when you enter to when you leave is really small, right? If nobody else is really in the system, you get out of the system faster, right? So if you have lower utilization, you have lower cycle time. And that hopefully should make sense, right? And so it should make sense as I increase my resource utilization. So if I go on the x-axis to the right here, these red and green lines are getting bigger. Okay, that hopefully intuitively makes sense. As you have more and more utilization, you're going to have more and more weighting. Okay, and that's just like a property of the world of physics, right? You have more demand for your stuff, you're going to take longer to get through the system because every once in a while you have to get behind somebody in line, right? So hopefully that is not crazy. What I want to ask you a question about, though, is these red and green lines. Can you, use some words to maybe describe, how would you describe these red or green lines? Like, are they flat? Are they linear? Are they non-linear? Are they, what do they come to mind?
They're sharply inclining. It's basically a 90-degree angle.
Yeah, so that is the big key takeaway and why this rule of thumb around 80%. So the key thing about this graph is that these are non-linear functions. And so, what we see here is they kind of start out linear, right? So if you take this red line or this green line, they're basically flat, until about this point for this green line, about 80% or a little bit more, then all of a sudden they skyrocket up, right? And so that is exactly why you don't want to have 100% utilization. Because if you're over here at 100% utilization, or even at 99% utilization, you're in that part of that curve that's almost skyrocketing, almost vertical, right? So your goal in terms of capacity is to get as far, you want high utilization of your resources up until it hits this spike, right? So you can expect kind of the flat line. When the flat line starts changing, that's really where you should then set your kind of utilization. And that's how you could calculate capacity. And so hopefully that makes some sense. The other thing on here is there's a red line and a green line. So what is the difference between the red line and the green line? It's the variability. So if you see here, if you have low variability, so thinking about like release of like orders into your warehouse, if day to day, you basically have the same, like it varies a little bit, right? You have plus or minus a little bit, but for the most part, it's the same. Then you can operate in this green line, right? But if you have really high variability, so like one day you have, like, let's say Mondays, you have 3 times as much work as, let's say, a Wednesday, then you're in a high variability situation, right? And you can think about like at the holiday seasons, those are extremely high variability versus kind of other points, right? And so if you're in this high variability, what you see here is, unfortunately, the world just gets worse, right? So if I have, let's say, 80% utilization with low variability, I have on average for this graph, maybe like you're waiting 2 hours. But on the high variability, if I go up to that, I'm waiting on average about like 8 hours for this high variability case. And so one key takeaway from this is, as you are correctly identified, is that we do not want, this is not a linear function. The second thing is that variability is bad. Okay, so for higher variable systems, you have to basically have lower utilized resources to have the same level of service. And so if you've heard of, things like Six Sigma or lean manufacturing, those principles, a lot of them are about reducing variability. And this is exactly why, is if you have lower variability in your system, you can have resources that are higher utilized, which means you need to invest in less capacity. Okay. Any other questions about my graphs here or anything?
No, I think, your description of peak season is very on point, because every season starting around, they're starting to think about it right now, literally. They know that all chaos is going to break loose, and they're all thinking about, their SKU counts, and some people have thousands of SKUs in their warehouse. And what are people going to be buying, and how many people do I need to staff to get those things out the door?
Yeah, no, perfect. And variability is the villain, I would say, in supply chain and logistics. And because of the demand, just like what happens in the world of demand, your companies need to be dealing with that. And that's just a hard part of the business. And there's some other things you can do smartly. If we have time today, we can talk about them as well. And so one thing I'm going to draw here with, I guess, these lines is going back to, okay, why did I say this 80% utilization? So if you have low variability, where I drew this kind of vertical green line, that's basically where the green line is basically linear. And then after that, about 80%, that's where it starts skyrocketing. So if you're in this low variability case, you could use an approximation of about an 80% utilization when you're calculating how many people or how many machines you should order. But if you're in the high variability case, you really, around this about 60% utilization is really probably all you should be doing. Otherwise, what you're going to do, if I'm over here, you're going to have a lot of customers that are going to be disappointed because they're late, or you're having your workers do a lot of overtime because you're not catching up. It's not balanced and you get behind. And so that's, again, kind of the answer. So to go back to our simple example, how many people to hire, I would make the case, it depends, how variable is your system? How much is your demand variable? But you can think about other things, maybe it's a supply side variability. There's other reasons, but if you think about just demand requirements, day to day or hour to hour, if you have a relatively low variability, I would say hire 6 people. If you have high variability, I would say hire 7 people. And, some of you are going to say, okay, I need, it's really hard to get labor. I need to make sure my labor is really efficient. I need to be cost effective. Sure, you can hire 5 people, but that's going to be a facility that's always going to be fighting fires. So if you've ever gone to a facility and you say, wow, they're just always fighting fires, one fire after another, and then you go to another one, it just seems to run smoother. One of the things might be they've incorporated that they're not using average performance. They're incorporating that there's variability in the system when they make decisions. And so I would make the case that usually cost effectively, it's more cost effective to have 6 people because you're not always behind, you're not expediting things, you're not having to manage all the fires that comes with always having to catch up. So again, I still haven't fully answered your question, but I would say 6 or 7, depending on your variability. And so this is my last, slide, just to go back, is that, a rule of thumb is to not just calculate something assuming 100% utilization. Anytime you need to make kind of investment decisions about something that has pretty consistent, like once you buy this machine, you'll have it for quite a long time. Or once you hire this person, if they're a full-time person, they're not seasonal, you're kind of with them over time. Think about using at least not 100%, and depending on how much variability in your system, 80% is a good rule of thumb. It is a rule of thumb. So in other words, if you have more specific information, you could draw that curve for your actual facility and then figure out where does the line start going crazy up, right? But the idea here is, you want high utilization, like that's a good thing. But at high utilization, the trade-off of that is you either have high work in process, if you're a manufacturer, high cycle times, high waiting times, you're late on your orders, depending on kind of how your business is structured. So that's, my lesson for today. And my takeaway for you is when you need to calculate some resources, don't assume 100% utilization.
Fantastic. And that's actually, I think I understand this finally. It's just great. And I know a lot of our customers are probably struggling with this exact same question today. How many people do I hire? And I guess the key I learned, my takeaway is the whole utilization factor. I think that's the missing component that I wasn't taking into account earlier. One other thing you're passionate about and you've spoken about in the past, and I think maybe help offset capacity, is flexible warehousing. So maybe you can take a minute to kind of chime in a little bit about what that is and what people could maybe think about for their own businesses.
Yeah, so this is kind of another way to think about capacity is what if I don't have to invest in, let's say, a building or capacity at such a long period of time? So one other area that my research team is very active in is what's called flexible or sometimes on-demand warehousing. And so there's actually a number of different companies in all around the world, actually. So from the United States, Europe, Asia, Africa, there are platform systems that operate where instead of you building, let's say, your own warehouse, or even contracting with a 3PL for long-term capacity, signing a contract long-term for capacity, there's what's called on-demand warehousing. So Flex is one of the leaders in the US. Where2Go is a UPS company, and there are many other companies in the US. And so the cool thing about this, if you're looking for trying to figure out this capacity problem, is you don't have to commit that long, right? You can commit for, let's say, a month, instead of when you make a commitment when you're building your own facility, maybe that's like 5 years, right? And so just think back 5 years ago, would you have predicted COVID? Would you have predicted what's going on right now? And likely most of us, I would say no, right? And so the shorter amounts of time means you have more opportunities to kind of update your decisions, right? So if you were off and you said, oh, our demand is lower than expected, you can make your capacity go down. If it's higher than expected, you could ramp it up, but not have to stay there for the whole time. And so it's just another kind of decision or lever that is useful. And in that ways, you could, in theory, have higher resource utilization than what I just showed because you're not stuck with a flat line, right? You can actually change your capacity quicker. And so that's something I think also worth looking into for many companies if they have really seasonal variability needs, or if they're just not sure, like they're going into a new market and it's really uncertain. They're not sure what's going to happen. This on-demand warehousing space is a good option to think about capacity as well.
Awesome. So, we've learned a little bit about, how to plan for people and maybe how to plan for inventory and flexible warehousing. Jen, I want to thank you for joining us today. Is there any way you can share how people might want to get a hold of you if they want to learn more?
Yeah, thank you. And thank you so much for having me on. As I said, how you and I met, I'm always looking for challenging problems, whether to motivate stuff in my class, whether to work on as a research problem. So if you have one of those, please send me an email. My email is on the slide. I also maintain kind of a blog that has more details. So for example, some of our work about on-demand warehousing has actually been published in the MHI magazine. And I have, that posted and more information if you're interested. I'm also on LinkedIn and Twitter. So any of those are great ways to get a hold of me. And I really am interested in just keeping a pulse on what is happening in this industry and using kind of math and data and computational tools to help do a better job in this kind of complex environment that is a supply chain. So.
Awesome. Well, Jen, thanks for your passion and your continued work in this. It's a great space to be in for our customers, and it's changing, it's challenging, and sounds like you're turning out great students who are well prepared to tackle the future. And thanks for joining us today, and we appreciate it.
Yeah, thank you.